Just like the glucose and fructose ring formation, we are going to now study the ring formation of D-ribose. Watch the video on D-glucose first and then go for practicing ribose and fructose. Okay. So Pyranose is six-membered. For ribose, the ring formation for six-membered ring is going to take place between C1 and C5 carbons, and for furanose, it is going to take place between C1 and C4 carbons. So this is the fifth carbon and this is the fourth carbon. Let's see how the orientation takes place. So let's look at the pyranose structure between C1 and C5. So this is fifth carbon atom OH is involved in the formation of oxide ring. New anomeric center is generated. OH can go on the right hand side or OH can go on the left hand side. Okay, when it goes on the right hand side, this anomer is called as the alpha D anomer. So this will be alpha D ribo pyranose structure, and this will be, when it goes to the left hand side, it will be beta D ribo pyranose. And the middle one is D-ribose, which is the Fisher projection formula. This is your Haworth projection. This is your Haworth projection. Now let's see the orientation. Start with the C-shaped carbon atom. You can start from fifth carbon or you can start from the first carbon. First, second, number it so that you don't go wrong. Show the bonds. Right hand side bonds groups go down. Left hand side go up. Since it is ribose, all the OH groups are on the same side, so it becomes easy. Now, if you look at this, the orientation is quite proper, so no need to orient the molecule because the attack can directly take place, and this is how the formation takes place. So here you get alpha and beta. If OH goes on the right hand side, it gives you alpha. If you are writing OH on the left hand side, it gives you beta. Write the alpha and the beta form. Start with the pyranose form, six-membered ring. Show the oxygen, number the carbons. Do, don't make any mistake here. Show the anomeric carbon. First form is your alpha form. So we'll put OH down. Rest according to the Fisher projection. You can put the OH. Fifth carbon atom. If you look at fifth carbon atom, there are two hydrogens, so you don't have to bother where to put them. And then similarly you can draw the beta form. Number first, show the anomeric carbons. First carbon is anomeric in this case, put OH up, H down. Rest remains the same. In ribose it's very easy to remember because all the OH are on the right hand side. Okay, so this is your alpha D ribopyranose. The difference between alpha and beta anomer is only on the first carbon atom. That is why they are called as anomers. No, watch the video on anomers. Okay, since it is a six-membered ring, this is going to exist in a chair form. So we can also draw the chair forms. So first I will draw the chair form of beta because there is space over here, and this is your chair, right? First draw the axial bonds, one up, one down. Then show the equatorial bonds. Okay, show the equatorial bonds, sorry. Then if you want, first number it. Fifth, first carbon atom, just like this structure, plain structure, you can put the OH. The groups on the top or above will go above, the groups below will go below. This is your chair form. This is your beta form. Similarly, we can draw alpha. I will draw somewhere over here, maybe. Sorry. Sorry for squeezing the structure, so, but no, don't want to rub it. Okay, so H, OH, number it and just start placing the hydrogens, and sorry for that. Done. Okay, this is O. Hmm? This is your alpha form. You can see, you can show the symbol for the anomeric carbon. Okay, this was your Pyranose form. Similarly, you can draw the Furanose form where the cyclization is going to take place between first and the fourth carbon atom. So show the oxide ring. This is your alpha form. This is the new anomeric carbon generated. This is your beta form, new carbon generated. You can show the oxide formation first. Okay. Similarly, orient it this way. Now we are drawing the Furanose structure. So let's orient it properly. CH2. First you write it this way and then check whether orientation is required or not. If orientation is not required, no need to do it. If orientation is required, you will have to orient it. How to check whether orientation is required or not? Just look at the carbon atoms which are going to take part in the cyclization, whether they are close to each other or not. They are not close to each other, orientation is required. In the previous one, it was between fifth and first carbon, so they were quite close to each other, but here it is now between fourth and first, so see they are far from each other, so we need to reorient without change in the stereochemistry at C4. So let's reorient it first. Okay, so how you going to reorient? You are going to orient in such a way, you need to bring your OH over here. So to bring that OH over here, you need to push this over here, this down. So we will write it this way, because anyways we are going to write the structure, no? So CH2 goes over here, H comes down, and then rest of the structure remains the same. So starting with the, this is your now fourth carbon atom, this is your fifth carbon atom, this is your third, this is second, this is first. The structures on the second and the third remains the same. Now you, it is properly oriented. Now the reaction can take place, cyclization can take place, and now you will get your two forms. So first you will draw the Furanos form. So draw a nice Furanos ring, number it, cyclization between 1 and 4. See 1 and 4 cyclization. Show the bonds. Same thing here as well. This is your anomeric carbon. Okay, first carbon, what is it? If you're writing the alpha form, what we are going to write? OH down, beta OH up. Rest exactly same. It's ribose, so all OH are always down. And what is there on the fourth carbon atom? CH2OH. Okay, here I will write it. This is CH2OH. You can write it this way: H, OH, H, OH, H, OH. Put here up, H down. So here this is down. So this becomes your alpha D ribo. Uh, Wait, I'll write here. This is your alpha D ribofuranos. Okay, and this becomes your beta D ribofuranos. Okay, so alpha beta. This is how you get. Since it is a five-membered ring, there won't be a chair form. If it was six-membered ring, then you can convert it to the chair form. Show the anomeric carbon symbol. This is your alpha form. This is your beta form. Watch all the videos on carbohydrates and I'll be making more. Thank you.